Okay, so next up in the last talk of this morning, before we head into lunch, which should be starting at 12, is by my good friend Brooklyn Zelenka, another Vancouver resident, and an Ethereum and a core developer, and a proposal which has been hanging around for a while, and I hope it will happen soon. Come on down, Brooklyn.
Thank you. Right. All right. Hi, everyone. So as Bob mentioned, it's right before lunch. I'm going to try to keep it as quick as possible, get some food in all of us. Prior to that, I'm going to be talking about ECIP 1050 or ERC1066 on ETH, which is smart contract status codes. First, a little bit about me. I'm Brooke. I'm XSpeed, basically everywhere on the internet. I'm the co-founder and CTO of a company called Fission. We do, the short version is a decentralized Firebase with user-controlled data built on top of things like Ethereum and the interplanetary file system IPFS. I'm a programming language theorist and VM enthusiast, and previously did a lot of work as an Ethereum core dev, but now I'm mostly visiting from IPFS land, just because we're mostly working on storage these days. I'm the co-author of a number of EIPs. The two ones of note, I guess, are making changes to the EVM instruction set architecture to add subroutines and static jumps, something that didn't happen earlier this year, but now there's a lot of interest in again, so that would be really nice if that happened, and status codes, which is what I'm going to be talking about today. And on ETC, that's ECIP 1050. The big goal of this project is three things. One, to help people write less code, i.e. introduce fewer bugs, ship faster, all of that. Have a higher confidence in the code that you are shipping and get better feedback about it. And make Ethereum more accessible to everyone. My 75-year-old grandmother in the Czech Republic should be able to use Ethereum instead of keeping money literally under her mattress. Today, everything's in English and sometimes in Chinese, and that's just a totally foreign system to her. At a very high level, the core idea is we can borrow things from Unix or HTTP. So just like how we have status codes on the internet that let us do things like provide user messaging, automated services, do microservices, all of that, we can have the same general idea with status codes on chain that talk between smart contracts. Because it's, one of the design goals was portability, so it's a single byte, which is, you can use really on any computer on the planet, right? We can read zeros and ones and in chunks of 8. So 1 byte, and that also means that it'll work cross-chain as well, right? You don't really care about the provenance of a status code, just that it is in this format. Here's some reasons to care about this. I mean, really, the three main ones were prior, but it's also a dependency in several ERCs. Security tokens are using them, for example. So a lot of regulated tokens are using these messages. It's approved, but not actually yet implemented as a primitive in Vyper. And there's a lot of interest as well from people doing diligence work and smart contract auditing as well. It's also open to extension. About 40% of the codes are defined and approved so far. So these codes are all structured so that it's both easy for a developer to work with them, but also easy to automate them with directly in a smart contract. So we take a byte, we break it into 2 nibbles, which are 4 bits each. Here's an example of a code, 4.1. That's broken up like this. The first 4 are the category of thing, so time logic, off-chain flows, if somebody's authorized to do something, all of that. And then the second half is the actual reason. So you don't have enough authorization, right? Or it's a generic error. You'll notice that's backwards from HTTP, where 200 or 500 are generic, so that you start with the first digit and then the zeros to say this is a generic success or generic error. We flipped them around just because it was much, much easier to work with in practice to do it that way for the automated code portions. All of the even numbers are some kind of failure, and all the odd numbers are some kind of success. And then it gets a little bit more specific within that. So we often want to pull out that, that nibble. And then the other nice thing that we get from this is if you, say in the 0 column, so the first category is just 0, that's all generic, then the lower nibble is just what that one means, and we have this, this generic option as well. So in this case, B, we can just forget about the first 4 bits. As I just alluded to, this can be seen as a table, so columns and rows, where the columns are categories, time, range logic, agreement, off-chain flows, encryption, all of that. And then the rows are reasons, so some things accepted or started, or is out of range, or anything like that. And we can grab the 2 across, compose them together, and get an actual semantic message out of this, that we're awaiting a match. So even as a developer, you can use, there's a helper library for this, but you can also just, instead of having to memorize 256 codes, you just need 16 and 16, so 32, and you can reconstruct and read them directly. In terms of space, so again, 256 codes available in the space, we've defined around 90 so far. To put that in perspective, HTTP has about 65. So we're already more granular, with also a different design space, but more granular than HTTP already. The helper library, available on NPM, lets you do this in a more human-readable way. So you can break up the category and reasons and stick them together. So you can combine them or pull them apart if you want to do some analysis on it. Or there's some helpers as well for doing reverting to. So you can say, I expect a status code that's in this range, or that is a success, or that is specifically time logic, otherwise fail with a particular message. We can also automate the message portion of that too, which we'll talk about in a little bit. But for now, just know that it is compatible with revert, and you can put a hard-coded string message in there. A little toy example flow. So we have 3 participants on chain. We have some kind of token, a proxy contract of some kind, and then either a user or another smart contract or whatever it is. And then the lines are time. So make a request, hey, I would like to buy this token. So we'd like to buy for them. And we're not available yet. So maybe it's a security token and it's not been approved by the regulator yet, or there isn't enough token supply, more will be released later, whatever the reason is. So we're not open yet for business, but don't worry, we've cached that. We'll call you back when we're ready. And then that message can propagate back up. Some time goes by, the user is impatient and they ask, hey, is that done yet? And we respond again, 43, no, and then we can just revert the entire transaction because nothing actually happened here. Sometime later, this token is now open for business, the ICO is open, or the lockup period's done, whatever it is, and we can then say, hey, we're ready. You have a few users waiting in queue. OK, great, let's send those messages to buy for them. Great, that's complete. propagate that back out to the users. And there's been some discussion lately about having user messaging sitting in a queue for things that have happened while you've been away from your computer. You could push that into these messages into such a proxy and then have those codes translated into the user's language. Today, a lot of this is done with either assume that there's success, revert, or return a Boolean. The problem with Booleans is they're not very specific about what they mean. It's just a true-false, right? Success or failure, but sometimes it doesn't really mean failure. It just means like I don't have them on the list, or any number of these things. So here's an example from the real world where this is helpful. So in security token context, we want to check if it's allowed to transfer a token right now. And so we have a extract out this checking validator into a separate contract, so it doesn't have to live in each smart contract. So when you KYC your users, you don't have to do it for every single coin. It can just be live in, here's people that we know are real people and meet, whatever requirements, and then you can use that for all of them. And those can talk to other of these so that you have a partner that also does this or has different requirements across a border. They can talk to each other and make sure that everything's OK in a totally automated way. So the flow for that looks something like this. We have a token and a validator. We say, hey, I'd like to do this thing, and it'll talk to some of its friends. And today, we just get back false, right? So it might not be something that needs to be fully reverted. It just says, nope, they're not on my list. Maybe check some other lists. Check the next one. They are on my list. And then we check this last one as well. We check to another friend. And then we just get some trues back. And then we get back true. So we can't really do a whole lot with that without deeply understanding the smart contract that we're talking to. And even then, we're really only have this success fail or yes, no option. If we give a little bit more context, so in this case, it says the user is too young, right? They're not, we don't have them on our list for being, say, over 18. So you can actually skip this next check completely and then go and say, hey, is there anybody, is this user manually whitelisted by some other authority? And then it goes through that flow and can come back and say yes. You can propagate that single message back through or change it to be a little bit more contextual to your specific use case because you're talking through many parties with, that are trying to handle many different use cases. It can get more tailored as it moves up this chain. And again, these might be different authorities in different countries, who have different requirements for different things. So specifically for a validator use case, that's really important if you want to say, do some securities trading between South Korea and the States, for example. And finally, user feedback, which I alluded to a little bit earlier. So revert, something that we have now, etc, which is great. Back in the olden days now, something would go wrong and you just get an out of gas error. It's not very helpful. Now we have hard-coded messages. And it would be really great if users could get messages translated in their own language, localized and understood, directly on chain. So using status codes, there's 256 of them. This is a translatable amount of data, right, or a number of messages. It's not an inconceivable amount of data to do this with. So you put a location preference contract on chain, and then let people register localizations. There doesn't have to be special, official ones. Anybody can register one of these and plug it into this system, and then set themselves as using that. So as a demo, in the repo, we have English, Spanish, and pirate speak. So people can really add whatever they want into this. So a success flow looks something like this. We have a Japanese-speaking user. They want to talk to a smart contract. And they have an ETC wallet. They send a transaction that either does a read or a mutation on chain, doesn't really matter, and it sends back a status code. And that's actually the transaction is now complete. So the rest of this is just a lookup. So it actually costs 0 gas, right? So we'll say then separately, OK, so what's the text for this? I look at the user preference for tx.origin on my previous transaction, grab the text out of the translation, propagate that back up to the wallet, goes to the user, and we can display this right in the UI for them, while recording the generic status code for other people, like the number, so that other people can look at it and have it translated into their language. Let's look at a revert flow. So I have another user, another wallet, another smart contract, and we ask them to do something, and it sends a transaction, and that transaction reverts. So one way to handle this is to revert with just the code and handle the translation in the wallet directly. We don't have that built into wallets yet today. So we have helper functions for revert with this code, which goes and grabs the text for that, looks up the translation that the user has set, sends it back, and includes it in as if it was a hard-coded string, but hard-coded in the user's language. Which works with how revert messages are shown today. So status codes, obviously inspired by Unix philosophy and HTTP, which leads us to a networked web of contracts. So Unix and HTTP have a lot in common. You should be able to plug anything together, and you should have these chains of functionality that work, and it shouldn't, the idea is that you're not going to build everything totally from scratch every time. You're going to talk, in HTTP case, over the network to another service that does something for you, or to, in the Unix case, over a pipe to some other process. ETC and ETH are shared systems. And what people are mostly doing today is taking a bunch of smart contracts, sticking them together, editing a bunch of portions of that, overriding them, and deploying them. So even if the original contract was fully audited, we have proofs for it, everything, and then somebody goes and starts overriding functions, the proof's invalid. Right? So having deployed high-quality smart contracts that, let's say, QuantStamp or Consensus Diligence have looked at and certified, and that the whole community can say, yes, we understand how this thing works, and we can plug into it, and it'll work the same way every time. The data inside of it is maybe very useful. So even in that case, deploying my own, I won't have that data necessarily, becomes very useful and needs to have a high degree of reuse. Right? We need to be able to talk to it from many different use cases that the initial author hadn't necessarily thought about in an automated way that doesn't require human intervention. And then the last portion from this is state rent, or even just collecting fees, because you can obviously send money along with the transaction. Is there a business model here for high-value data and high-value utilities on-chain making money? So it's almost potentially a business model for open source smart contracts. Would look a little bit like this, just as a diagram. Right, so we can have some top-level dApp talking to several different smart contracts that can then, in turn, talk to others and others over a common interface, a common protocol. You could create new protocols, just like how TCP has this whole handshake. You can create more protocols out of this, back and forth with these status codes as well. As I just mentioned, you have these pluggable, high-quality, reviewed, security-hardened smart contracts. Which would be really lovely to see as ETC moves forward to build these out and make it much easier for people to get involved in developing smart contracts without having to know about all of the subtle quirks that can happen in smart contract programming. So thank you very much, and I'll let you get back to lunch.
questions?
So what would this look like from the perspective of a smart contract developer? Yeah, so what would this look like from the perspective of somebody who's writing a Solidity contract integrating with these codes?
So let's see if I can just grab an example. All right, great. So here's a simple example. Instead of returning a Boolean, you return a byte. And that one byte is the status code of what you're trying to communicate back. So it could say things like, you're authorized, right, 0x11. The developer may put that in, hex and then 11, right, in Solidity. Or they can use the helper library, which would say authorization success, and then send that across. And it'll turn it into the byte for you. That costs a little bit of gas because now you're taking two enums, which are uints underneath, sticking them together and then casting it before you send it. But it's a little bit more readable. You can also consume these. So you'll get in a byte. You can look at it directly or pull it apart and do some analysis on this is success or failure. And there's an entire helper library with about 30, 40 functions to help you do that, and even do things like revert unless it is in a certain range.
And just to follow up on that, would this, let's say this standard were to take off, would it basically become like like safe math, for example, where there's like thousands of implementations of the same code, or is there any way that we can basically just create one thing in the blockchain and then everybody just plugs into that?
That's exactly the hope, is that you can deploy contracts right on chain that use this to tell a little bit more about what's going on in the response, makes it more reusable. And now people aren't redeploying the same safe math or ERC20 or whatever. We re-architect those. Safe math is actually a really good example because it doesn't require anything else. You can just call into it. And then exactly use safe math, which is, if you look at how smart contracts and Solidity are designed, they should be delegating out to on-chain, other on-chain contracts, but they're not right now. Yes.
Thanks for the talk. I was wondering, you mentioned that there's some support to Solidity coming, or in the works?
Vyper.
Okay, sorry, Vyper, yeah.
Yes.
Well, on that note, is there anything in the works in regards to Solidity, like for maybe some way you can just like throw the error and it'll automatically return stuff or something like that?
Yeah, so that's what the helper library is trying to do. You can just use it with revert or require. There's a helper require OK function in the helper lib that will, again, you can either say require OK will require it be an odd number, or there are further ones that say require a particular status code or a particular category or reason.
Cool, thanks.
Yeah.
I got one here. Can you talk a bit about the Vyper integration, what that kind of looks like?
What the library looks like?
Yeah.
Yeah, sure. I mean, I can also show you literally the library after, but it has enums for category and reason to help you read a little bit better. So you're not just looking at just straight numbers all the time. You can say this is, time out of bounds, for example, or time expired. It has functions for working in different types. So if you don't want to be working in hex, you can be working in uint8. You can pull a status code apart into the category and reason. There are helpers for translating between that. There's one column for application-specific codes. So if you have something that's not covered, you can define those. And there's a translation to get from that into this library. And then a bunch of things for revert and translations.
You're saying it costs a bit of extra gas to do like the string conversion. could there be some sort of extension to Solidity where you wouldn't have to have that extra gas?
Absolutely. We'd have to build it into the language directly. I would love to see that be the case, but you know.
Cool.
Yeah.
Thanks.
Yeah. Great, thank you.
Thank you, Brooke.
Thank you. Ooh, yum.
So that's this morning. We're done. Go eat food outside, and we're back here at 1. Thank you.